Welcome back to the second part of Chapter 1. So hopefully by now you've watched that short clip from the West Wing, which gave us a window into understanding how maps can be kind of deceiving, right? Because we're trying to take this three-dimensional object of the Earth and display it on a two-dimensional map. And some things are going to get distorted. We're going to talk about different types of maps, as well as some mapping technology for the second half of this chapter. And so what we want to do, though, initially is just to be able to understand maps, how they work, and we want to be able to think critically about what maps tell you and what they don't tell you. So here is a map of Europe, which seems pretty straightforward. What does it tell us? It tells us the countries that are in Europe. What this map also does is tell us the countries that are not in Europe. And so there are countries that might disagree with this, that might very much consider themselves European countries, but they are excluded on this map. So when we look at maps, especially of regions, we want to think very critically about what they say and what they don't say. I just want to talk a little bit about what a map scale is. If you take a physical geography class, we talk a lot more about scale. And if you took a physical geography lab, you would have to do some exercises with scale. But scale is just the ratio by which real world features are shrunk. And so we can see on this slide, we have a small scale map, which showed you a very large area. It's kind of counterintuitive that a small scale map shows a large area, but that's how it works. And then as we get to a larger and larger scale, we can zoom in first to the Southeast United States, then to the state of Georgia, and then to the Atlanta metro area. And so it does this by a ratio, for example, 1 to 24,000. These range from 1 to 95 million to 1 to 1.3 million. And what that means is that 1 unit on the map equals 24,000 of those units in real life. So for example, 1 inch on a map would represent 24,000 inches in the real world. So we have to make a choice between more space depicted versus more detailed features. We interact with maps on our phones. For those of us with smartphones, who it's just about all of us these days, with maps all the time, and we are able to zoom in on our Google Maps quite easily and change that scale based upon our needs. And but on a printed map, we need to know exactly what the scale is. On your phone, when you're zooming in and out of your maps, a little scale bar will actually pop up and tell you what scale that you're at. So again, here is two different map scales. The first one in map A has a ratio of 1 to 1 million, which means an inch on the map equals a million inches in the real world. This is very useful if you want to understand the Bay Area, where Oakland is in relation to San Francisco per se, but you want a much larger scale map of 1 to 10,000 if you are somewhere in San Francisco and let's say I want to know how to get to Fisherman's Wharf. We want to make sure that we're using the right map for our needs. We're going to talk about longitude and latitude and why they are important. And they are very important, right? We use them for maps to let us know where we are on the planet. Latitude goes from the North Pole to the South Pole, from 90 degrees north to 90 degrees south. You can only see up to 30 degrees south on this rendition because the bottom is not visible to us, but you're never going to have a latitude that's more than 90. And it's either going to have a north or south hemispherical marker. Longitude runs east to west, divides the planet into eastern and western hemispheres. It goes from 0 to 180 degrees. And so if you have a number that is 121 degrees, you know that has to be longitude because it's greater than 90. And that is going to have an east or west hemispherical marker. And one easy way to remember which one is this that I find, latitude is like a ladder, right? We can almost imagine climbing up latitude. So I'm going to talk about each one of these separately and why they are important. But together they make this very nice grid that covers the planet, that lets us know exactly where we are. We can get pretty precise with these coordinates and kind of navigate our way around the globe. So we'll start with latitude. Latitude is how far north or south something is from the equator. And the equator is 0 degrees. The North Pole is 90 degrees north, and the South Pole is 90 degrees south. It divides the planet in between the northern and southern hemisphere. And latitude is divided into degrees and then to minutes and seconds. And so there are, in any degree of latitude, there are 60 minutes and then 60 seconds. And the way has nothing to do with time, it's just a way of getting that measurement more precise. And so again, we go from 0 to 90 degrees, and then within each one of those degrees, we will have 60 minutes, and within each minute, we will have 60 seconds. Those lines are called parallels, and that's because they run parallel to one another from the North Pole to the South Pole. So the distance between these parallels is the same wherever you are on the globe. So no matter where you are, 1 degree is the same distance as it is anywhere else. Each degree is equidistant from the next. And we're going to learn that that is not true for longitude. And so why is latitude significant? Latitude can tell us something about a place. Lower latitudes, and by lower we just mean closer to the equator, not necessarily north or south, are warmer. And we know this pretty intuitively. If we're closer to the equator, it's going to get warmer. Higher latitudes are generally colder. And again, higher latitude does not mean north or south. The South Pole is at a very high latitude of 90 degrees and it is very cold. So just remember, high does not equal north. It means far from the equator. Antarctica is at a high latitude. And so people often get confused about this. This is a picture from when the World Cup was in South Africa, which took place in the summer. But the summer, when we are having summer in the northern hemisphere, the southern hemisphere is having their winter. And so depending on what the elevation was in South Africa, it was quite cold during the World Cup. So a lot of the fans were quite bundled up. And there were a lot of people on Twitter saying, I don't understand why people in Africa in the summer are wearing winter coats. And that's because the seasons are reversed, right? South Africa, parts of it can get quite cold during their winter, which is during our summer. And so again, we have this nice grid that longitude and latitude create, but we can tell something about a place based upon how far it is from the equator. Here's the equator right here. And so if we look at San Diego, which is about 33 degrees of latitude, if we follow that 33 degrees across over into Europe, we actually have very similar weather to southern Italy and parts of Greece. Our climate is a Mediterranean climate, which is named for that region. And so if you know the approximate latitude of a couple of places and know something about them, so for example, San Diego is 33 degrees north, Portland, Oregon, which you may or may not know, a lot of people do, Portland, Oregon is chillier and much rainier, and that's 45 degrees north. And then you have a place like Anchorage, Alaska, which is 61 degrees north, which is much, much colder. So if you know something, the approximate latitude of a few places, and you know something about their climate, you can infer something about other places when you find out their latitude. And so again, we want to make sure that we are talking in terms of directions of north and south, right? When we talk about what is above the United States in this picture. The sky is above the United States. The ground is below the United States. So we want to make sure that as geographers, we are talking about directions in terms of north and south or east and west. Next, we're going to talk about longitude, which differs from latitude in a couple of big respects. It is how far east or west something is from the prime meridian. The prime meridian is 0 degrees, and the prime meridian runs through Greenwich, England. There used to be several prime meridians, unlike the equator, which is a location that is based in the physical geography of the Earth. It is the warmest place on the planet. The prime meridian is an arbitrary line that we just use to start counting from. And so there used to be several prime meridians, and then about 30, mostly Western nations got together 100 and some odd years ago, and they said we really need to pick one so that all of our maps match. And at that time, England was quite a global power. It had colonized many places around the globe, and so they got that prime meridian. It divides the planet again into those eastern and western hemispheres. We are in the western hemisphere. And just like latitude, it's divided into degrees, minutes, and seconds between 0 and 180 degrees. Those lines are called meridians, not parallels. They're called meridians because they are not parallel. They actually converge at the poles and get closer together. So they are not parallel. So that distance between degrees actually changes depending on how far you are from the equator. And again, they converge at the poles. So you can tell here the distance between 10 degrees is much greater right here than it is as you get farther north. And so how is longitude significant? It's not really. It doesn't tell us anything fundamentally about a place. What it does do is we loosely use it to determine time zones. Time zones are also divided along political borders in the United States, along state lines. Time zones, though, you can see here, China has chosen to be all on one time zone. So sunrise happens at different times for people in that country because it's a very large country that's all divided into one time zone. So longitude is not really significant other than the fact that it loosely tells us time zones and it allows us to have that grid that lets us know exactly where we are on the planet. And so just a little recap, we have lines of longitude and latitude. We have the Western Hemisphere and the Eastern Hemisphere, the Northern Hemisphere, and the Southern Hemisphere. So if I give you a coordinate of longitude that is 33 degrees north, 13 degrees west, you know that it has to occur in this quadrant because it is north and west. And again, those seasons are reversed on the other side of the equator. In physical geography, we talk a lot about Earth-Sun relations and why exactly that is. But this is Christmas in Australia, still December 25th. But for Australians, Christmas happens during their summer, not their winter. Next, we're going to talk about the types of maps. There are two main types of maps. The first one is a reference map, and that's really what you're interacting with on your phone most of the time. It's just telling us general features. Here is a map of the 48 contiguous United States, right? It's just letting us know where things are. Thematic maps displays a certain theme or a certain type of data. We're going to look at a lot of thematic maps. I'll show you some examples throughout this course, but thematic maps can literally be anything. Here is a map of dog states versus cat states, right? Apparently California has more cats than it has dogs, but you can display all types of data as thematic maps. Here is a map of global internet usage. So generally speaking, places that are more populated and wealthier have more internet usage. You can see over here, here's the Korean Peninsula, South Korea, which has an open government, has lots of internet usage. North Korea, no internet usage, as it is not allowed there. Here is a thematic map looking at Facebook usage and Facebook connections. So you can see things like Hawaii has a lot of connections to the mainland United States. Makes a lot of sense. We can tell things about migration based upon this. In England, there are many people from India or of Indian descent. So we have a lot of Facebook connections between India and England. Here is a thematic map that looks at every place the United Kingdom colonized at some point. I said that's why they got the prime meridian, but the expression was the sun never set on the British Empire because they had territories and colonies all around the globe, including a good portion of the United States at one point. Here is a map of happiness, right? So using some type of rank to see which countries generally have more happiness and which have less. It tends to be very correlated with wealth and also with civil liberties. So next we're going to talk about map projections, which is a lot of what that video that you watched from the West Wing. And so we're looking at ways of portraying that three-dimensional Earth in a two-dimensional space. And so all projections have to distort. Some distort size, which that Mercator projection that you saw in that video does. Greenland gets much, much bigger in a Mercator projection compared to Africa than it actually is. Some distort shape. And some distort both size and shape. In fact, a lot of ones that we would use more typically today distort both of those as a way to have a trade-off, kind of give us an idea of what things look like, but also not have something size-wise that is so distorted. That Mercator projection is still everywhere, though. If you buy a map shower curtain at the store, it is likely to be that Mercator projection. In schools, depending on when is the last time they updated their map, they might have that Mercator projection, and it really does greatly enlarge the northern hemisphere countries, such as the United States and Europe, Iceland, Greenland, compared to South America and Africa. And so we use different projections for different purposes. If we want the relative size of countries, the Mercator projection is not very good for us, but the Mercator projection was really good for traveling the ocean. And so we want to think critically about who made the projection, what is the projection doing, how is it distorting? And again, all projections are going to have to distort somewhat because we're taking that three-dimensional globe and trying to display it in a two-dimensional space. And so there are other examples, not just world maps. On the left here, we can see a plane projection right here, which is basically just if you were looking down at the North Pole. And so if you wanted to have a good idea of just how close Greenland and Russia and the United States are, this might be a good projection to use. This is an orthographic polar projection. We can use a conic projection to look at smaller parts. It says if you peeled a piece of paper off the globe. And so here we can tell how those lines are moving. We can see how this map might be distorted. Here is another projection looking at the North Pole that has divided the South Pole into 4 pieces. Right? So again, things over here are going to be more accurate than things towards the South Pole. We also want to think critically about maps when we see them. Maps have often been used for propaganda, for different political entities to have different goals. Here's a map that was used by Nazi Germany during World War II. And they're saying, we're not really the aggressor nation. Look at us and our size. We're very small compared to all of these other countries that we are currently at war with, which did not really give an accurate representation of how many countries Germany had invaded or how it had gone beyond its borders. there is a great book that this is from. It's called How to Lie with Maps. The last two things we're going to talk about are different types of mapping technology. And after this, you're going to watch one more short video and then move on to your country journal. But we want to think about, here's a map of land use and land cover in the state of Tennessee. We want to think about, how is this map made? Like, how do we know that these areas are deciduous forest and these are non-forested wetlands? And so it used to be that we would have to go out and survey all these areas and try to make a map. But now we're able to use satellites and something called remote sensed imagery. Remote sensing is very big in geography. Lots of people use remote sensing. Here is a map of the 2007, or an image rather, of the 2007 California wildfires, which that smoke could be seen from space. There is a group of people at San Diego State University called the Hazard Mapping Corps, and when there are large wildfires, they kind of snap into action and will help map out the locations of these fires using remote sensed imagery. Um, Something else that we use in order to get this remote sensed imagery and know exactly where it is GPS, or global positioning systems. And so after this, you're going to watch a short video on the history of GPS. But basically, we have satellites orbiting the Earth. If you are in a place without a lot of light pollution at night and you look up and you see lights going across the sky, you could find satellites fairly easily. There are lots of them. 20 years ago, there were a lot fewer satellites. You would have to wait a lot longer to get enough satellites to get your location. And now, at any given moment, there's probably about 16 satellites that can help get your location, which is one of the reasons why our phones are so accurate. And the last thing I wanted to mention is GIS, or Geographic Information Systems, which I encourage everybody to take a GIS class at some point when they're in college. GIS is a great tool that a lot of industries are using. It's one of the reasons that geographers have some of the highest employment rates when they graduate college. Everybody from UPS to fire science to emergency management teams use maps like this and make maps like this in order to accomplish different goals. So that's the end of the second part of chapter 1. You're now going to watch a video about the history of GPS, and then you are going to go on to your first country journal entry, and that will be the end of module 1.